Hello and welcome to this TGA digital video on how to do an animated transition effect shader using Unreal Engine 4. With this transition shader, we'll be able to transition between two different looks of an object, and we'll also have an animated effect where the transition occurs. So let's get started building this shader. In this video, I'm going to show you how to make this kind of animated transition shader, if you will. Doesn't necessarily have to be this kind of fire effect that I did. You could imagine it being an effect for a power-up you pick up in game, or having a wounded character transitioning into a healthy character when being healed, or a similar kind of transition where you want to go from one material to another one and have an animated effect sweeping by the object, if you will. So I'm using a few textures, and I'll start by showing you these textures. I downloaded, I think, this one, and this one are all from CG Textures, or it's now called textures.com, right? So these are just hardly modified at all. I just had to align the amount of planks here to get this in between space with this one as well. This one was a fiery effect, a photograph of a fire, I think, and I had to, mask it out and duplicate it around just to fill. And it's not that important, the general look of the overall image, as this will just momentarily be shown in the animated transition area. The main point is that I want to get the colors of fire right, and I want to get some kind of variation. This one is used as a secondary effect, and I think I downloaded this from Pixabay. It was a free texture as well. These two are the height derived from these textures, and this one is derived from this one. There's also this one which I just created with render clouds in Photoshop. I think I used a median to get a blurred version, and then I just copied one pixel row like this and then stretched that in these directions. And the point is, I want it to be the same value when going in this direction, but different in this direction. And it will be used later on to offset the animation. So that's my starting point texture wise. I downloaded pretty much all of these in the beginning when setting up my project, but you can go ahead and do them whilst you're doing your project when the need appears, if you will. But the base is having two different textures to start out with. These will be used to help break up an otherwise quite monotone transition, and be used as various masks also. So to get started, I think I'll show you this here program, a really nice, neat little program which I like a lot. It's called Graph. It's a web page called Padawan. You can just Google it. It's a nice freeware program to plot graphs, and might not be that exciting at first if you just think of this as your high school math, if you will. But once you start seeing this as possibilities when it comes to animating effects and seeing colors in these curves, it kind of gets exciting, at least if you ask me. So this here is the graph that I've drawn that symbolizes the transition which appears in Unreal. So if you imagine that intense width or line going here, that line is this peak here, and this is where the fire appears, and this is where the burnt material is, and this could be the healthy plank. And there's a bit of transition area as well where it fades out, right? So once again, there's my peak. So I will be using this as a mask, if you will, to where to apply the materials. And this is the calculation to get this result. And I didn't get this from anywhere. I just constructed this myself, if you will. You can just start out by, if you want to play around with doing graphs, you can insert a function in this program. And start off with the function being function x equals x, for instance. That will just give you a linear line like this. And then from there you can go try different math functions to see what they do. What happens if I multiply it, for instance? Well, we're changing steepness, right? What happens if I add a value or subtract a value, for instance. I now move this upwards, if you will, or downwards. If you imagine this axis representing a surface, let's say a polygon plane or the box I had in Unreal. This is, you could imagine this being either from left to right or right to left, or this could be the bottom of the box, and as I go this way I'm going towards the top of the box. And this one, this axis would represent 0 to 1 here, would represent the brightness of your mask. So this would be a black color and this could be a white color. So for instance, if I subtracted 0.5 here, you could see that I've now got, let's say this is my bottom part and this is my top part. So the bottom of the box is going to be completely black here, or actually negative values right now, until I reach a quarter of the distance, you see, 0.25. And then at that quarter it's going to start transitioning towards a white color and hit the white color at 0.75, I think. And then from 0.75 to 1 it will appear white, but I will actually have a value which is greater than 1. So this is how you would start by getting the kind of transitioning mask, if you will, to get your results. So now I just increase the steepness, for instance. If I wanted to cap out at 1 and at 0 here, you could add the range function. A range and parentheses, and then first you set the minimum value, which is 0, then a comma, and then the maximum value, and then a comma, and then your input, which is the calculation I have at the moment. And then don't forget the end parentheses. And that's the result I get. So that's what I've done to get this curve here. The trick to get it to peak and then bounce again is to use the absolute function, which is just abs. So if, for instance, I were to wrap this inner part, my previous calculation here, within an abs, that is ABS and stands for absolute, what that does is it strips away the minus sign. So my curve used to go below 0 here, right? But it strips away the minus sign. So a value of, let's say, negative 0.2 becomes a value of positive 0.2, if you will. And that makes it kind of like bounce. So that's what I've done here to get this peak and then bounce down again. From here on you could just go ahead and multiply by -1, for instance. Oops. Obviously not over there, right? I think I'd need to contain it within my abs. So, no, actually after my abs, I think. I want times -1 at this point, I think. No, well, obviously I'm missing something here. Either way, here's my calculation I did to get this, and by all means do play around with it. I've written it here and I'll try to just show you how it works. I have a variable called y here, it's inside here, and y is my driving factor, if you will. This is going to be where in the shader I input time, the game time, so it will increase this value all the time. And what happens when I increase this value, right now it's set at 0.0 here. When I increase it, this peak here will appear to move to the right. So let's just try increasing that value. Let's set it at 0.5, for instance. That should put the middle of this peak at 0.5 here. Yep. So as time is increasing smoothly, it will appear to shift like this. And that is what is driving this here transition line here, if you will, driving it upwards like this. So y is my driving factor, the time. I have a steepness variable which is currently set at ×8, as you can see, multiplied by steepness, and then it's at ×8. What this does is set the steepness here, that transition area. So if I wanted a less steep, I could go for ×4 instead of ×8, and you will see that it should end like here somewhere, I think. Yep. I've also got something called peak width, which is that last added value, and that is the width of this peak. Actually, what it actually is Let's see if I can move around. I think it's this one, right? So it's set at 0.3 now, and 0.3 represents how far from here to this peak. So this one caps out at 1, and I think if you were to leave it here, the peak would be at 1.3. Either way, as you increase this value, you get a wider peak here, if you will. So let's say I didn't want this peak. I could just remove this value or set it at 0, for instance, and I'd get this. So I wouldn't have that white area of pure white there. I would just barely hit white, or I would hit white and then dip down again. And if I wanted a wide peak, I could go 0.5, for instance. And I might actually go for a wide peak and let's say a very steep value, like so, for instance. Yep, but enough of that. I do recommend you try out this program if you want to work with animating effects or just manipulating values using math like this. It's a good way to visualize colors in this spectrum, and this could be, it could be time or a distance or a position or a rotation or whatever. So enough of that. I think I'll jump back to Unreal now, and the trick here is to, when you're building from a calculation like this, at least the way I like to approach it is I do the innermost calculation first, the innermost parenthesis, if you will. So x minus y in this case, as I mentioned, x was this curve here, or this axis, and in my case I wanted it to be a direction. I wanted it to move across the surface, so I settled for the direction going from down to up in my case. So that would be my direction where I'm currently, where I'm located on the surface, if you will, and this will be time driving. Now the trick here in Unreal, I hadn't planned for this originally when doing this tutorial, but I did like the doing it this way. It's way more neat and cool, I think. Initially I used the UV space as my way to position from left to right or bottom to top or whatnot. But I would just have the effect going, for instance, from here, left side to here. And same on this surface. So I would have the fire beginning here and at the same time over here. And it didn't look complete in that sense. It looked nice for just one surface. And same thing here. I might have the fire here and going that way. But now it's taking the whole object into consideration, if you will. And that is because I did not use UV this time. I used the object's local position. That is, for each sampled point here in the shader, it would see where is it located in relation to the rest of the object. So I could choose a value which would go from here or there or whatever, and it would work for whatever kind of object, if you will. I would get a bit funky result if I had an object, you know, that would, let's see, if I had an object that would go inside and do all kinds of crazy loops like this, that kind of object might look weird in certain cases, but for a pretty standard box-like object like this, I can get away with this kind of transition effect. So to get started, I can just show you, this is kind of like the network I have for this shader. And I'm not going to go exactly step by step in this. I'm going to show you the core principles, and I can do a fairly quick walkthrough of what I've done here to get this kind of effect. But I will show you and give you the tools to create your own kind of effect like this, if you will. So the key nodes we're going to approach doing here is getting the local position. So let's start by making a new shader, and we'll create our own shader for this video lecture. So I'll go material, and I'll call this lecture transition. There we go. I think I'll go ahead and add this here, and I'll just double click the material to start working with it. Now for this material I don't want to involve light at this point. This is just a tutorial to show you how to do transition effect. You can figure out doing the same kind of transition for your normal map and roughness and metallic and all that stuff later. So for that reason I go ahead and set this start material to unlit, which means I'll just be working with the emissive color, and that's about it. I don't have to worry about these other two. Then I'll go ahead and I'll create this node called local position, was it? Object local position, this one, MISC, local position. And local position is going to give me a value, this one, if you check the help documentation for this, this one is going to give me a x, y and z value for the sample point. So if we look at the object, this cube here, I think that, if I'm not mistaken, we can try it out. I think it has its center point centered here. So for instance, in the y-axis, I might have a value of 0 here in the middle, and I'd get a positive value here and a negative value on this side. And the width of this box is, let's see, it's a few hundred units, if not, in Unreal. If I check the details here, you can see that the object, it's actually positioned by centimeters, I see. So if I were to move it halfway down, you can see that the difference there was 40 centimeters. So that would put this at around 80 centimeters, if I'm not mistaken. So 80 by 80 by 80 centimeters. Could be 100, I think. Yeah, that's probably it. So if I move this down to, it's positioned at 80, no, 70 now. Well, either way, it doesn't really matter, since I'll be creating a smart way for the user, so you don't have to set the size of the object yourself. But what I wanted to say is that it is a few units, and I think I have a center line at 0 here. So I might have 0, positive 40 and negative 40 here. So what we can do is just break out one of the directions, and to break out one of the directions you can use a node called, I think it's mask component, or is it component mask? Here we go, component mask. And with this node you can check here which channels you want, and you'll get a new output data stream just containing those channels. So let's just try it out. Let's try the red channel and see what that gives us, which should be the X direction. I think it's X, Y, Z. But let's try connecting that into emissive color and then just saving this. And I'm probably getting a crazy amount of glow here, or yeah, not in the viewport, but as you can see here, I have a center line here, and you see it corresponds to the X direction. So I have 0 here and probably a lot here and a lot negative here. So depending on which direction you want the shader to go, you could settle for this. If I wanted it to go this direction, I'd probably want to find the other axis as well. Let's go ahead and try that. So I could just switch around here and see if I tried G, for instance, which should be X, Y, Z. Does not seem to be working at all for some reason. Could it be that the cube, I think in Maya, I think I set my my center point or my pivot point to be at the base, or was it here, which probably puts all of this in negative space, I think. Let's try the last one as well and see what that looks like. I think this is the one we want to settle for either way. Yeah, that's the one I want. So probably it was the other direction, I think. I always get confused between Unreal and Maya, since up direction is Z in Unreal and Y is depth, if you will. Either way, this is the direction I used for my transition effect and the one I'll use for this example. So next thing which we want to do is to have we want to rescale these values, because ideally we want the value to be 0 here and 1 here, or the other way around. It's not easy to work with having minus 40 and positive 40 here, if you will. And one way could be to if you had the size of this, you could multiply by that. But an even more nice solution, if you ask me, is to actually use the object's bounds. The object's bounds, if you're not familiar with that concept, is pretty much you could take any 3D object and then you create a cube which perfectly encapsulates that object, and then you can measure that cube to get the object's width, depth and height. So there's a node in Unreal which you might have saw it in my shader. I think it's called local object bounds, or object local bounds. Object local bounds, there we go. Now object local bounds lets me get the local bounds minimum values, the maximum values and the size. And same as the local position, this size here should be in XYZ. So if I'm using the third channel here, that is the XYZ channel here, I want to use the Z component from this stream, which should give me the size of the object, or the Z direction, that is the difference between the lowest point and the highest point, which if I'm not mistaken and I've been saying the right thing, should be 80 centimeters. So let's see. My idea here is if we take 1 divided by the size, we should get a multiply factor, which we want to use over here. So we're going to go ahead and see if that works. So I'll want the mask here again, and you can click Control C and then Control V if you want, or just Control W and you get a copy in Unreal. So I'll connect this to the size. I want to make sure that it's the same. You see it says B and B, which is good. I then want to take a divide node, so I can drag from here, and I could either right divide or just the divide sign on my little numpad on the keyboard works fine as well. And I don't want it this way around. I want it to be 1 divided by the value I input. So it's 1 at by default, but if you want to make sure, select the node and see what the A channel contains. So right now I might have 1 divided by 80, for instance, which will give me a pretty small number. But that's the number I then want to multiply this stream with, to shift this value from being 80 to instead being 1. That's my plan here. So I could drag from here, let's see if that works, and just type the multiply sign on the numpad. Or actually you can use the M key on the keyboard. Hold down M and left click to get a multiply. I then want to multiply this value by this value. And I think I'll go ahead and just click this one to see it on a polygon plane as well. Now this is quite annoying. I think I'm not that used to working in Unreal, to be honest, but I think I can disable this here. I might be able to, at least. If not, I could go ahead and just add a clamp node here, and the clamp node would make sure that any value of 0 would be black, or a negative would be black, and if it's way over 1 it would be clamped down to 1. The default values are 0 and 1. So let's go ahead and try this multiplied value and see what that does. Did not work entirely correct, because I think if you saw earlier, the polygon plane, I think it ends down here if I'm not mistaken. So I do have a bit of transition here, but it's not entirely correct yet. And that is because I had, let's try and save this as well, see what it looks like in the viewport. Yeah, I had my center line here before, so now I've probably got 0.5 up here and minus 0.5 up down here. So what I want to do here is probably just go ahead and add a half, since I want to shift this line downwards here. So if I go ahead after the multiply, I can drag. It's more easy to drag from this side than this side. If I do like this and put an add node, I get this, and I have to connect it manually. If I go from here and drag it this way, it inputs it in between, so that saves me a bit of connecting. And I wanted to add 0.5. There we go, and save that result. So now I've got 0 down here and 1 up here, which is good. Now we can manage using this value to position our effect much more easily. Yep. So the nice thing about this, to reiterate, even if the box was a lot bigger or a lot smaller, I wouldn't have to change any values to take into consideration the size of the object. I get that now because I'm using the bounds to rescale the value here with the multiply node. So this is the x part of my equation here, or my calculations. As I said, the x, this axis, was the direction of the object, and I wanted it to be between 0 and 1, which I do have now since we rescaled the value. So the next part is the y solution, and y is going to be my time in the game. So we want to, as it said, subtract this x by my time. So I think I'll go ahead and just move this to the left to create some space. And then either on top or down here, I think I'll go for down here, I want to create my time. So in Unreal, you just type time, you get the time node. And the way it works is, I think this is, I might be wrong here, but it won't reset itself. I think it will just keep on increasing all the time. And one way, at least when just working with effects like this, to just repeat it and show it over and over, is to use a modulus node. And that is called fmod in Unreal. So if I use an fmod, I can then input a second value here. Yeah, I'm not able to type it in here. So if I hold down the 1 key and left click, I get a constant. I think you can right click and type in constant as well. This is the equivalent to float in other programs. So this is how many seconds I want the value to increase before it repeats itself, if you will. So let's set it to, let's say, 5 seconds, for instance. So what this does is the output I get here will go from 0 to 5 seconds. Then after 5 seconds, it will jump down to 0 again, and then go up to 5, and down to 0, and up to 5. I think you can actually visualize this in this program. Let's try that out. I'll just select a different color. I will use a mod. It might not be this way you write it, but let's see. X, 5, for instance. And if I zoom out enough, you'll see that this yellow line, yellow might not have been the best color towards the white background, but it goes to 5 and then it jumps down to 0, 5 down to 0, and it does this infinite amount of times, if you will. And that's what we'll be doing with the time in Unreal. So even though the time is increasing, if this were time, even though the time keeps increasing, I always get an output which goes 0 to 5. And that's really nice when previewing effects like this. So I've now got this time repeating itself, if you will, and I'll use this to subtract from here. So make sure, if you're connecting like me, that you do the subtract in between here and not after the clamp. So I can drag from here and subtract. And we subtract by this value. And let's just see what that gives us. This is what it's going to look like. And for the most part, it will look black now, since I'm subtracting for a whole 5 seconds. But the key point here is that the white gradient I see there at the beginning, it animates, it moves across the surface. So think of that white part as a mask, if you will, and it's moving across the surface. Same thing we did here when we shifted the value of this one. We shifted this for 0.5 as an example. Let's say we put it at 0.6. You will see that this one will move a bit this way. So that's the kind of effect we've got in Unreal now, even though we don't have the entire solution yet. So after subtracting, and you know the time solution here, the y, I can keep on improving this later on and tweak it to my liking, but let's stick with this for now. So next step is to take the next parentheses. So now I'm done with this parenthesis. I'll now multiply by what will be my steepness factor, if you will. So that is, after this subtract is this one here. I want to multiply by my steepness, which will be here. So I'll go ahead and drag from here. Just type in the multiply on the notepad on your keyboard, and this will be my steepness value. So let's put it at 8, for instance. And I think I'll just repeat this a bit more often so we can see the result a bit more often. So let's see what that does. So as you can see, before we had a big transition from 0 up to 1 here, and now we've made that transition a bit shorter or more narrow, if you will, and that is the width here, this steepness. Next part is we're done with this parenthesis now, or actually that's my absolute, so don't forget about this abs. This parenthesis and this one comes from doing the absolute function, and that is what makes this one bounce. we haven't got that bouncing effect yet, as this is pure white, entirely white here. We just want a line going here. We don't want entirely white on this side. So let's add an absolute, and that node is called the same in Unreal. So I can just drag from, let's see, subtract, multiply, then comes the absolute, since this was the subtract, this was the multiply, and then we do the absolute. So drag from here and type ABS as in absolute. And that is the kind of results we see here. Let's just view it in the viewport as well. Yep, seems to work. And I'm not done yet. You might wonder that it seems to be black here and this one seems to be white, as this is white color. But that is because I'm multiplying by -1 here later on, which should flip it upside down. And oh yeah, I tried to do this here and I failed, and I see why now, because I think the thing is, and you'll see, if I just go -1, I should put this one down here. And since I'm doing the range as well, and range clips off at 0 and 1, since I have a peak down here and it clips at 0, I just get this flat line all the time. I need to move it upwards again, and that's the +1 here. So this peak down here gets moved up, if you will. Or actually, you have this result now. You move it downwards and then you flip it. Or yeah, that should be it. We can break it down here if you want to see it in action. So if I just remove these two, oops, there we go, -1, and we remove the range as well. You'll see what's going on. There we go. So I've got this peak going this way now instead. Before we did the -1, this is what we have now in Unreal. You have white, and then we have the black line, and this black line is shifting this way, right? So always white and then a black line shifting, and that corresponds to this look. Next step was to go -1, so times -1, like so. And that, if we did that in Unreal and previewed it, we'd only see black, since this is below 0 and we don't see any difference in the black color, the visual representation. So I'm just going to do one more step here before we go and do this in Unreal, and that is after the multiply by -1, you put +1, which will again move this upwards. And now you have this peak which hits 1 here, and you'll have black and then white and going back to black. I can just add the range here as well, just to make sure. And in graph you write range, comma range, and then the minimum value, comma the maximum value, comma the calculation you have, and then end parentheses, and that clips it off here. So in Unreal we now have to multiply by -1, add 1, and this is called clamp in Unreal, this range here. So times -1 plus 1 and a clamp. So we already have the clamp here actually, so that leaves us a multiply by -1, and then as you can see we now have a black result, and then we need an add node. So plus sign and add 1, which is the default value. And that should now give us a white, as you can see, a white line instead. And you know, it's not super important. You could just settle for having it inverted, if you will. It's no big deal. I'm just used to having white represent the intended effect, and the intended effect in this case is that fiery effect. So that's the concept of creating a shifting line like this, if you will. Next step could be that we could now use a Lerp node to choose between two different objects, if you will, or textures, sorry. So at this point I've already got my textures here. If you're not familiar with it, you can just take the textures and not the PSD, or actually you might be able to, but just drag and drop this into this area here. And now that I've got them here already, I can go ahead and choose, say, my burnt planks and my healthy planks. And I'll go ahead and create a Lerp node. So just type in Lerp and you get the linear interpolate. I want, let's see, actually this is not the gradient we want for these. I'm mistaken here. Eventually we want to do a transition between this one and the burnt planks, but right now I'll settle for just the healthy planks, and then I want the fiery effect. So I'm going to go for the fire texture, this one. So, I'll connect this one over here and this one over here. And when it comes to Lerp, the Lerp node, the white color is going to be the second value, B, and the black color is going to be the A. So I can take the clamp from this point, connect here, and then take the result of the Lerp and show that instead. So this is what we've got now at the moment. And as you can see, it's starting to shape up to look similar to the transition shader effect I had earlier. I will definitely make some modifications to break it up more and make it more visually interesting, but we've now got the base effect, base animated principle, if you will. So you could at this point, since this is going to represent fire and I have this emissive here, Unreal is quite nice in that sense that if I just multiply this value higher, I should get stuff like bloom and get that intense look going on. So I could just drag from here, choose a multiply node, and you can go ahead and tweak these later if you want, but let's just set a higher value and see what that gives us. I don't think it will be a super big effect, but it does look a bit more intense. So let's keep on pushing and try to make this more interesting. Next step is going to be we could settle for, in this connection here, we want to make it so that we have both healthy and unhealthy planks, or burnt planks, if you will. Actually, burnt planks is more correct. Healthy is just a funny way of putting it, I suppose. But another thing we want to do is to make the transition more interesting. And one way I did that is I used this texture. This texture I used to just break up the concept of time. So let me show you what I mean by that. If I just go ahead and take the fire animation offset texture, which was this one, which only had variation in this direction and none in this direction. I could now go ahead and add a subtract node here, for instance. And I could then add one of these channels here. Since it's black and white, it doesn't matter that much. And then we can look at what that looks like. I'm not sure why this one gives me this kind of results, but it should look more correct here. Now you can see that I've got a more interesting line, because it's not entirely monotone and symmetrical or the same all over. So what's going on here is that depending on where on the object we are, with the concept of time is shifted. So we might have a time of, let's say, 2 seconds here in the gray area. And then over here, since this is subtracting, I will get a different time when I'm at this color. So since this is subtracting, that would put this at a higher time, so maybe 2.05 seconds, and this one is 2.03 seconds, and this one is once again 2.05, and here we have 2 seconds, etc. But the point is, if we have different concepts of time in different vertical positions here, we should get an offset like that on the object, which is what we're getting. So at this point I can tell immediately that I've got too big of a difference for what I was looking for. So I might go ahead and just step back a bit on how much I want to offset time. And to do that, we could just add a multiply node. Oh, that's not it. This one. We could go ahead and just add a multiply node here. So I think I'll just move these around a bit, like so. I don't want the lines crossing like that. I think it's more neat to see it like this, more easy to see it. So I'll create some space here, I'll drag from here, I'll add a multiply node, and You could of course update the texture as well, but if you want the user to be able to tweak parameters or just for previewing before making the edit, I can just go ahead and multiply here instead. So I think I'll step back to something like 0.4 or 0.3 or something like that. And let's see what that looks like. Yeah, that's better. I think it's still too much, I think. Still clicking the wrong shader, 0.2 for instance. I think that goes a long way. We don't need to over exaggerate too much. Yeah, that's kind of good. Let's see. I almost forgot one thing in this shader, and that is we might want to add this optional peak width as well. Right now we just implemented the times -1 and +1, but if we want we can create that peak as well. And let me show you what that looks like. We've got this kind of result now. It should update and show me here, which it is not doing for some reason. Let's see if I click this, if I can get it updating. Oh, that's sad, that's sad. That time is increasing definitely. The F mod is also shifting. You can see it goes from black to white. The subtract gives me that kind of result. That might be the reason, since this is going upwards here. Anyway, you're usually be able to see the visual preview here, which is sad that I have lost that functionality. I'm not sure if I'm doing something wrong, but this generally works for me. Either way, we can just add another value here, or actually increase this one. Depends on how you want to make it. This one there should always be 1, I think. So I like to break it out as 2 add nodes like this, because later on you could then expose this as an input parameter for the user and just call it width if you want. If they leave it at 0, you still get that add 1 here, but if they want some width, you get 1 and then an additional value as well. So let's just set a width here, for example. Set it at 0.2. What it should do is it should make that the width of that effect, it should make it wider. And if I keep clicking the wrong my earlier shader, if I lower that value, I should get less of a transition width, if you will. I think the reason why we still have quite a thick line now is because I used to have this transition area. I used to have this value as well. But since I increased the intensity of the fire texture, it appears to be a lot wider. It will be more intense in the middle, but I will still get that fall off will appear to be quite a lot of fire as well. I think if we try to just back up on that multiplier to see what that looks like, you can now see that I've got a more apparent transition, if you will. And depending on if you like the visual result of that transition or not, you could go ahead and... No, that's not it, this one. You could go ahead and add a power of node, for instance, in between here, which would make... You could have it dipping below like this with a power of node to not have as much transition, but still have just a little bit of amount. So a power of node here would give me that kind of result. I could set this at 3, for instance, and then add the intensity as well, which should give me not as thick line, but I still have quite intense now. So that's working quite alright, if you ask me. And we've now broken up the transition line, so it's not as boringly straight like we had before. So at this point, let's go ahead and see if we can add that burnt texture as well. So to do that, let's see, where's my shader? This one. To do that, we have to step back here, and we want another Lerp node here. So I'll go ahead and drag from here, and I'll type Lerp. And this node is going to go from healthy to burnt. Or it might be the other way around, and we can just shift them around. It depends on what areas of the mask are going to be black and white in the end. But the point is you want to add these into a Lerp and then have another mask to drive these. Now we're going to do that mask in a similar fashion to this one. And let's jump into the graph program just to see the kind of results we want. So the kind of mask we want now, if our transition, if the fire effect was here at this point, we'd want that other mask to be 0 all the way here and then go straight to 1 here. That's the kind of result we want. So to get that kind of result, I think we could actually, we'll use a function called seal. We can create a new function here. Let's add x and let's add seal. It's as in sealing, which will take any decimal value and increase it to its nearest integer, if you will. So any value which is larger than 0.0, let's say 0.3, will be 1. 0.8 will be 1. As soon as I pass 1 and I get 1.001 or whatever granularity we have, it will jump up to 2 and 3. So we don't have any decimal part now, we only have integers. And let's see, I think if we now just, let's remove the seal for now, I'll just type x again. If we now can take this line and move it down by the same amount we did with this one, I think, if I'm not mistaken. So we get this part here crossing at exactly minus 0.6 and then add the seal. That would make the line go like so. Hold on, let's see if I can show you. It would go like this and then like over here. If we add the seal at that point, I would get minus 1 result from the seal, and then exactly as it increases above 0, it would jump up to 1 here. So let's try that. And the reason why this peak is directly above 0.6 is because we set this the time value here, my example time value, to 0.6. That is the y part here. So I think, if I'm not mistaken, the calculation we want is seal x minus y, and that would be seal x minus 0.6, and 0.6 because I'm using the same example value for this other line here. And let's choose a different color as well. Let's go for blue. Yeah, oh, I missed this bracket. Yep, and blue is also the line of these axes, so let's pick something else. Let's go for a green color. And as you can see, it's 0 all the way here, and then as it hits here, it gets 1. So let's try and create that in Unreal and see what that gives us. So, should be easy. X, if you remember, was my solution, my positioning solution based on the local position in the object. So this entire block is my x, and y is my time solution. So that is this entire block is my time solution. So I should just take this one minus this one and do a seal. So first the inner parts, x minus y, that is this one minus, subtract this one, and then the seal, which is also available in Unreal if I'm not mistaken. So seal as in sealing, there we go. If we look at that, let's see if that updates correctly. Oh, that's a shame. Let's see if I close these other ones, if that is the issue here. No, I don't know. Well, why not? So you should be able to see the previews with these buttons. It should update live in this little viewport here. But for some reason I've lost that, which is a shame. Try on your end, it might work. But if we just try connecting this as our output color, and let's just see what that gives us. It looks like that, which is perfect. This can be used as a mask for where to apply the healthy texture and where to apply the non-burnt planks and the burnt planks. So as I said, white color represents the B channel of the Lerp. So I want the white part here to be the healthy planks. So I'll put the healthy planks, the non-burnt planks, lecture transition, the non-burnt planks in the B channel. So I'll have to shift these around. like so. And now I should be able to use this value, which we just previewed in the alpha channel here, the mix part of the Lerp, and then plug in my previous solution here. Let's see what that gives us. Ah yeah, we've got one issue as well. Yep, and that is because if we go into graph, you can see that this value can go below 0 and above 1 and 1. And when using a Lerp node, you don't want that. So it's usually a good idea to clamp before inputting a mix alpha value into Lerp if you're unsure if the value goes below 0 or above 1. So clamp, just to make sure, and we'll save that and see what it looks like. So there we go. We've now got two different textures, and we've got this glowing effect on top. So I think those are the key principles here. As you could see in my previous effect, I had set the time just to be multiplied to go a bit slower. I also had these glowing embers as well, and the glowing embers is actually pretty much the same as what we're doing already. It's a matter of creating the type of mask you want. It's similar to this mask, but it has a slower fall off like this for the embers. So I think I'll go ahead and show you just how I built this one. Let's do sort of a breakdown of this one, if you will. So make sure we have that material applied here. We do. I just want to mention, I didn't bother with doing this in any more fancy fashion, since I'm already doing lots of new things in this shader. I stuck with being happy with this. You could also, of course, if you wanted to, try to create the effect so that it would go outwards like this and into the middle if you wanted to. But right now it takes all of this pretty much at the same time, since it's positioned. I get the same Z position values on all of these points. It's just offset a bit by these in-between parts here, if you will. So if we look at this shader, and this is the one I prepared before the lecture, you can see that I'm pretty much doing the same thing here. I have the object position, I'm rescaling with the size of the object. I've got my time solution here. I'm doing a bit more stuff here to be able to set the speed of the time and have the user be able to set that easier in the end. I am also offsetting time with the same kind of texture here. What else? Yeah, well, I'm also modulating this transition line here. I'm not happy with just having that time offset, so I'm also just using a little bit of the height from the healthy planks and a little bit of the height from the burnt planks and offsetting by that as well. So that's what's going on here. I've got, let's see, I've got this solution here with the Lerp with the burnt planks and the healthy planks, and I'm doing the same kind of clamp and the sealing here as well. And yeah, I'm doing the clamp on the other end here and the other shader, and it doesn't really matter which order you put them, to be honest. I've got this track here, which was my peak like this, the fire effect, and I've got another peak here as well. And the other peak is for the Ember effect. That is, I'll be using, I'll show you. We can go ahead and steal this calculation. We'll create another function. Let's add that there. Let's make it a purple or pink. And the difference between those two peaks is that I used a much lower steepness value. So I get a longer tail, if you will, for the burning embers. And I think that's pretty much it. What else? Yeah, I've got a little bit of peak on the actual fire effect. I've got 0.2 as a peak on this one, so we could add that as well, just to visualize it. So I got this little peak here on the fire effect, and this purple mask here will be for the embers. So yeah, as you can see, that red ember color stays a lot longer. It has a lot longer tail, if you want, and that is due to the steepness here. So what else? yeah, I didn't want the Ember texture here, this texture, I didn't want it to show all over. So as you can see here, the Ember texture just shows on certain parts of this area. And I think in general, those parts are the lower parts, if you will. So that height texture, the height texture from the burnt wood, I used that and transformed the values to just get the embers to appear on the lower parts of that height information. So that's what's going on here. And it's just a matter of inputting these lerps into each other. And then this part, the add node here, is just adding the ember effect. Since I'm seeing this as light, if you will, I could just add that as a bit of an extra effect at the end. So if I were to remove that add and just connect this lerp, you could see that I wouldn't have those that red ember coloring. I would just have this fire effect. So that's what the last add there is for. So that's pretty much how I go about creating an animated transition effect in Unreal. As I said, it definitely does not have to be a fiery effect like this if you don't want. Create whatever kind of effect you want for your game or your project. It could be, for instance, a power-up, as I mentioned. It could be an idea that struck me. Let's say that you have a game with an in-game puzzle and you want to give a hint to the player. You could just have a faint swooping line like this to show objects that you can interact with, or after a certain amount of time, if the player hasn't figured out which object to pick up, you might want to just shift to using this shader and have a bit of shimmering effect across an object to help get attention towards that object, if you will. So I hope you've enjoyed this lecture and have fun creating your animated transition effects in Unreal. Please let us know what you thought about the video and what you want to see next. To see more, visit our website or follow us on Facebook and Twitter.